Climate change is a topic that we as a society cannot afford to ignore. Problems regarding our planet's climate will affect day-to-day lives now and into the future, and as such, it's wise to learn as much as we can about the nature of climate and climate change. In Mr. Sharp's Earth Science class, we attempted this through multiple means. Firstly, we studied existing information on the topic, learning useful terms and concepts, and doing research assignments. This background knowledge helped us in our second endeavor, collecting and analyzing first-hand data to get a more hands-on understanding of the effects of various factors on Earth's climate. One of the most important factors in Earth's changing climate is the greenhouse effect. This effect occurs when gases such as methane and carbon dioxide block energy from leaving the atmosphere, warming the Earth. These gases allow energy in the form of solar radiation to enter the atmosphere, where it is then absorbed by the planet's surface. When this energy is re-emitted in the form of long-wave radiation, it is reflected by greenhouse gases and is trapped above the Earth's surface instead of going back into space. This results in a net warming effect on our planet. The urban heat island effect is related to the greenhouse effect and is caused by the differences in surfaces' reactions to solar energy. Dark and dry surfaces, like asphalt, tend to absorb more energy, whereas lighter, water-based surfaces, such as grass or other shrubbery, have a higher albedo, or reflection rate. Therefore, surfaces with a lower albedo remain warmer than lighter, high albedo ones. This causes problems in cities, where low albedo surfaces like asphalt roads, concrete buildings, and tar roofs abound, and cars create a higher concentration of greenhouse gases in the atmosphere directly around. These factors combine to increase the heat of urban areas significantly over rural ones, to the detriment of city inhabitants. Aerosols, or solid and liquid particles suspended in gas, are the final climate-affecting substance we studied as a class. The only well-defined and understood effects of aerosols involve global cooling, whether from directly reflecting the sun or from increasing cloud coverage and therefore indirectly reflecting the sun. The former occurs as a result of particles blocking certain wavelengths of energy but not others, so that long-wave radiation may escape, but UV radiation enters less successfully. The latter happens when the particles of aerosols function as condensation nuclei to create longer-lasting clouds made of smaller droplets, which reflect the sun better than clouds in areas with less aerosol particles. The significance of aerosols in the atmosphere can be measured by a sun photometer, which takes two readings: the aerosol optical thickness, or the direct prevalence of aerosol particles, and the percent transmission, or the percentage of sunlight which successfully filters through aerosols into the atmosphere. As a class, we set out to observe elements of all these effects ourselves by collecting data over a period of 2 months in locations around our school. Our class divided into groups and spread out, using infrared thermometers to measure the surface temperature of various locations, including an asphalt parking lot, a concrete sidewalk, the grass of a practice field, and the turf of our school's football field, among others. Each group took the temperature in 9 different areas of the surface, and several other Earth Science classes collected data on the same locations throughout the day, giving us a large sample size and a more accurate average daily temperature. In addition to surface temperature measurements, our class also recorded cloud density each day, and used a sun photometer to measure aerosol optical thickness and percent transmission. Here we see a chart representing the data collected by all of Mr. Sharp's Earth Science classes in November of 2012. During this month, data was only collected on 2 surfaces, the asphalt parking lot and the grassy practice football field. In the December graph, there was again a clear correlation between temperature averages for all surfaces on any given day. Surfaces with a higher albedo are cooler, while those with a lower albedo are warmer. However, the line from day to day for each given location is of a similar shape, indicating that fluctuations in day-to-day temperatures affect each surface similarly. Most of the data we collected confirmed existing information on the topic, suggesting both that our data collection methods were effective and that existing information is well tested and accurate. The one major point on which our data and research disagreed was on the effects of aerosols on the climate. The research on aerosols is inconclusive, but it suggests that they act mostly to cool the Earth, as previously mentioned in this video. However, when analyzing our data, this trend seemed to be reversed. As the amount of aerosols in the atmosphere increased, temperature also increased. This was initially surprising, but it ultimately confirms that the effects of aerosols are not agreed upon. The only thing that's sure is that aerosols must be further studied if we are to fully understand their effects on such a significant element of human life as our planet's climate.